Hello everyone, welcome back to the channel. In this tutorial, I am going to show you how to do 3D visualization using ArcGIS Pro. In our previous GIS tutorials, we have seen some basic maps like study area map, land use land cover map, and then contour maps. And if you are someone who is looking to learn GIS and advanced surveying, I think you are in the right place. Please subscribe to our channel and you will see more videos like this. Step 1. Firstly, we need some raw data to create a 3D visualization. For this tutorial, I am using this NASA Earth Data. Click on this Earth Data search and you can find the home screen like this. You can visualize the whole of the world and you can navigate to the particular study region. If you want to download the data, you must have a login ID. In the top right corner, click on the Earth Data login, and if you are new, click on this register and create a login ID. I already have a login ID, so you can see my name at the top right corner. After login, we must navigate to your study region. For this video, I am using Chennai as my study region and I am drawing a polygon to identify my study region. You can also draw a rectangle like this or even a circle like this, or you can drop a pin over to your study region. At last I am clearing all these things and drawing my final polygon. After drawing the polygon, you can see there are plenty of geospatial data available in these websites in different subcategories. Platforms, instruments. Under instruments, you can see the atlas, aster, and so much of data available. So whatever your requirement, you can explore these options, and based upon your requirement, you can find one. For this video, we are using this shuttle radar topographic mission, and the data format is HGT. And I need a resolution of 1 to 30 meter result. I have got some 2 results. You can see 2 matching collections are available for this particular study region which I have marked. You can visualize the tiles one by one. For my study region polygon, I have got 4 results and 4 tiles. So I need to download all these 4 tiles to cover all of my study region. So this is how you can download. Just click here and if you just left click, you can download the data. The most important thing in GIS is you must always create one particular folder, because GIS is a collection of different layers and different kinds of data, and there may be chances of confusion. In order to avoid those confusion, it is always better to have a unique folder for each of your project. For this tutorial, I am creating one folder and I have pasted all the downloaded zip file, and one by one I am extracting all of them. Now I am opening a new software called as QGIS, which is one of the famous open source software. Why? Because we have 4 different tiles. I want to merge all these 4 tiles to create a single tile. So I need to mosaic all this data. I will open this base map, which is OpenStreetMap, and I will navigate to the folder and drop it here one by one. After adding all the individual tiles, we are moving on to the next step, which is merging all this individual tile into single tile. Before merging, click on one of the layer and right click, go to properties and see the information about the particular layer. You can see the coordinate reference system, origin, pixel size. Like this, you can note down each of these layers coordinate reference system as well as pixel size. Now we can move on to merging. For merging, click on the raster, miscellaneous and merge option. Select all the individual tiles, and already we have seen in the information it is integer 16. Modify it and click run. Once done, you can see a new layer formed named as merged. We don't want the rest of these individual tiles, so I will select the individual tile layers and remove them. The next step is we need to reproject this projection. Based upon your study area location, you can do the reprojection. For that, you can go to this reproject option and select this merged tile. Select the coordinate reference system and you can select the place where this file has to be saved after reprojection. I will select the particular folder, the same folder, and name it as Reprojected DEM and click save. Now this has been reprojected and exported as a new layer. You can check the properties and then pixel size for this reprojected layer and then get rid of the previous layer. You can also go to the symbology and change this single band pseudo color to see the elevation differences in different colors. You can see the dark blue represents lower elevation and then red color represents higher elevation. Next, you can open ArcGIS Pro and create a new project. Here I am creating a new project named as 3D visualization in ArcGIS Pro, and I will select the folder where all this data has to be saved. Again, if you see, I am selecting one single file for this entire tutorial, and a new project is opened now. I will navigate to my study area, which is Chennai, and click on this add data. I have this Chennai's boundary, so this is my study area boundary. I will change the symbology in order to visualize the features inside this study region. If you check the properties, you can go to the source and you can see the projection information. The coordinate information is same as that of the raster which I have downloaded from EarthData Science. I have downloaded in one CRS, but later in QGIS I have reprojected and saved it. Now what I am going to do is I am adding that reprojected file, TIFF format file, and if you go and see the spatial reference, you can see the same coordinate reference system. So both my study area boundary as well as this raster is of the same coordinate reference system. I will move this Chennai boundary up, and in the geoprocessing I will search for an option called extract by mask. Why? Because I don't want the entire tile, I just need the boundary of my study region, so I want the raster to be clipped. For this purpose I am using this extract by mask and identifying the output folder here. you can customize your name as per your requirement and click OK, run. See, I have missed one information, which is the output raster should be saved in this geo database. I will name this as mask. Click OK and then run. Now I have a new layer. So this raster covers only my study region, so I can get rid of the old one, the entire tail. I don't want the entire tail, and just removing that one. Now you can see only for my study area boundary I have this raster. You can shift the symbology and see the color information. For my different elevations I have different colors. It is not that you have to select this particular color. Based upon your requirements and needs of your project, you can select different color options. Now go for Hillshade option. So this Hillshade can be found in geoprocessing, and you can input this mask layer. You can see an option called azimuth and altitude. You don't want to make any changes, just leave it to the default and click run. Now a new layer has been formed named as Hillshade. Just go to the properties and select this display, or else you can go directly to this symbology option. Change the color stretch type to standard deviation, so that you can get a visualization like this. And once again I will repeat, this is not a 3D representation. We are still working in the 2D format alone. So coming back, the next step is you can click on this mask and bring it to the top, and at the top you can see the transparency. Just reduce the transparency to around 50%. Here I will reduce the up to this 48 mark percentage. Now you can see a difference in the visualization of this DEM. Now what you need to do is, you can go back and click on the add data and click on the mask data as your elevation reference. So this will act as a elevation surface reference. Next, for creating a 3D visualization, you can go to this view option and create a local scene. So a local 3D map can be visualized. You can see a button like this for navigating. So this circle helps you, and with the help of your mouse you can shift over the angle. You can see the bumps there, the mountainous regions, or in the study region you cannot find so many mountains. Why? Because this is Chennai city and we can't expect more mountains or more bumps. The areas which are little elevated, you can see it is elevated. You can improve the vertical exaggeration to from 1 to 3, and you can see a more bulge. In order to have a better visualization, you can always select your study region as a hilly region. There you can see so much of undulations. Not only that particular layer, you can untick the remaining layers and you can visualize the 3D appearance on the screen. Like this, you can have multiple views on the multiple layers. You can see the differences clearly. through this visualization, 3D visualization. Even the base maps can have a 3D appearance like this with the help of this local scene option. The final step is adding grid to the visualization. For doing that, you can go to this geoprocessing and search for fishnet. Fishnet is nothing but creating grids in the 3D visualization as well as 2D representation. Based upon your study area, you can give the cell size width and cell size height. My study area is entire Chennai, so I am giving a try for 500 meters. But what I got is so much number of grid lines. I am measuring this grid exactly 500 meters. I am changing it to 1500 meters, which is 1.5 kilometers. I am changing the cell size width and run this one. I'll change the cell size height as well to 1500 and finally click this run option. Now I could see proper grid lines on my study region. I will get rid of this point shapefile. I don't want the points inside my grids, so I'll remove it. If you want points, you can have it on your study region. Now I have only the 2D appearance. I want the 3D map to have these grid lines. So what you can do is you can simply copy and paste it in your map 3D. So within a fraction of seconds, you can also see the grid lines appearing on your 3D visuals. So finally we have come to the end of this tutorial. We are going to create this 3D visuals into a map. For doing that, you can go to the insert option and I'll go to this import layout. There are default layouts out there. I'll select this one. Just get rid of the default map frame which is available on the screen. Delete the map frame and insert our 3D visualization map to the map frame like this. And thus we have successfully created a 3D visualization in ArcGIS Pro. And I think this video is helpful for you. I'll name this map as 3D visualization in ArcGIS Pro and export this one. For exporting, you can go to the share option and export it as a PDF like this. I hope this video is useful. Thank you.